Hi, good to see you again. Welcome to Block 2, Developing Geometric Reasoning, Lesson 6. I'll share my screen. So, in your previous lesson, you learned how to use knowledge of a geometric fact that sum of angles in a quadrilateral is 360 degrees. And you also learned another fact, and you made use of the fact that opposite angles in a quadrilateral are equal. In today's lesson, you're going to learn to solve angle problems using properties of triangles and quadrilaterals. Remember to like the video, subscribe to the channel, and click on the notification bell so that when new videos are released, you will be notified. Before we start, I would like you to pause video and answer the retrieval practice questions in 4 minutes. Assuming you've paused video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. For the first one, you can see that these are vertically opposite angles. So angle B must be 73 degrees. For question 2, we see that we have a 90-degree notation mark here. So that should be 90 degrees as well. And here we have 63 degrees. So we can use our quadrilateral angle solving fact that the sum of angles in a quadrilateral is 360 degrees. So when we use that fact, we'll find that 360 subtract 90, subtract another 90, and subtract 61 degrees will give us 119 degrees. For question 3, we can see that this is an isosceles triangle. So the base angles must be equal. So if this angle is 45 degrees, this angle must be 45 degrees as well. So we know that the sum of angles in a quadrilateral is 180 degrees. So if we do 180 degrees minus 45 degrees minus another 45 degrees, that will give us 90 degrees. For question 4, we know this is an isosceles triangle. So we can subtract 44 degrees from 180 degrees, and then whatever is left, we can divide it by 2 because the base angles of the isosceles triangle must be equal, and that is 68 degrees. Let's do some new learning for this lesson. But before we do the new learning, to review some of the angle facts that you have learned, I would like you to pause the video and answer these questions. would like you to pause the video and answer. Just a minute. To recap what you've learned, I would like you to answer these questions. So pause the video and try to answer these in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Here you can see that that is an isosceles triangle, so the base angles should be equal. But the fact that really matches that is that the sum of the angles in a triangle is 180 degrees. Apologies for that. For the next one, we can see that vertically opposite angles are equal. And for the next one, we can see that adjacent angles on a straight line are equal. For the next one, we can see that these are angles at a point. So the angles at a point add up to 360 degrees. For the last one, we can see that that represents isosceles triangle of which the base angles are equal. Let's do some new learning for this lesson. If you're asked to calculate angle X, how would you go about it? Well, let's simplify the diagram. Of course, you can now see that this simply represents adjacent angles on a straight line. So, to get angle X, we can simply subtract 130 degrees from 180 degrees, which will be 50 degrees. But what about the other angles? Can we actually find them? Can we calculate those angles? Well, we'll leave that for subsequent parts of the lesson. We'll discuss it again, but it's something for you to think about. At this stage, you can pause the video and answer questions 2 and 3 to practice what you've learned so far. Pause the video and answer question 2 in 1 minute. Assuming you've paused the video and you've answered question 2, here are the answers. Let's discuss them. So for question 2, you were asked to work out the sizes of angles X, Y, and Z and to give reasons for your answers. Angle Z must be equal to angle X, the vertically opposite. But we can find angle Y quite easily because we can see they're vertically opposite. Now, once we found that, we can subtract 2 lots of angle 52 degrees from 360 degrees, and whatever is left, we can split it into 2 because these angles are equal. And that gives us these angles that you see here. Okay, so we could use, there are different ways to do this. So another way is we can say the angles on a straight line is 180 degrees. So 180 degrees minus 52 degrees will give us 128 degrees, which is the angle here. And then if you know this is 128 degrees, that has to be 128 degrees, and that has to be 52 degrees because they are vertically opposite. Pause the video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. For question 3, we're asked to work out the size of angle S and to give a reason for our answer. Angle S, we know that it's on a straight line. So we know that we know that angles on a straight line add up to 180 degrees. So we know that S at 71 degrees will be equal to 180 degrees. So if we subtract 71 from both sides, that gives us our angle S, which is 109 degrees. So the reason is because angles on a straight line sum to 180 degrees. Then you ask, what is the sum of angles Q, R, and P? Q, R, and P. Well, we know that this angle is 109 degrees. So the sum of the angles in the quadrilateral is 360 degrees. So if we do 360 degrees minus 109 degrees, that will give us 251 degrees. Why? Angles in a quadrilateral sum to 360 degrees. Let's do some new learning. Here, AB and CO and DO are straight line segments. But she says angle K is equal to 50 degrees because AOC is vertically opposite BOD. Notice the angle convention. The middle letter represents the angle we're referring to. So we have said AOC is equal to BOD. Have you noticed the mistake? Have a think about what we learned about vertically opposite angles. Well, we learned that vertically opposite angles only work when the line segments are actually straight. Have you noticed that the line segment CO and OD or CO and DO are not actually straight? They're not a continuous line. So we'll disagree with Eva because if we continue the line, we'll see that only a part of angle BOD is actually vertically opposite to 50 degrees. So we'll disagree. So for vertically opposite angles to be true, the line segments must be straight. So they are lines that cut across, straight lines that cut across each other. Okay, let's revisit this question. Did you notice that this is an isosceles triangle? So these base angles must be equal. Therefore, to find this angle, we know that this is a triangle, so we can work out 180 degrees minus 50 and minus 50. So 180 degrees minus 2 lots of 50 will give us the angle Y. And that should be 80 degrees. It's now time for you to pause and answer some of the questions to practice what you've learned. Pause the video and answer question 4 in 3 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Let's discuss them. For question 4, you were asked, here is a quadrilateral. Angle ABE is 39 degrees. You can see it there. Label it on the diagram. So by now, you know how we use angle convention or angle notation. So the middle letter represents where the angle should be. So that's 39 degrees there. For B, you were asked, what is the size of angle ABC? So angle ABC. Have you noticed that if we were to produce another angle there, we would form adjacent angles on a straight line. So to get that angle, we would say 180 degrees minus 39 degrees, which will be equal to 141 degrees. The fact is, adjacent angles on a straight line is equal to 180 degrees. Here are the answers for question C, D, and E. So let's discuss them. But before that, I'm going to rub off these parts that I wrote before. For question C, we're asked, what is the size of angle CBD? And how do you know? Well, going back to the diagram, angle CBD should be 39 degrees. You can see that if we were to put a mark there, that would be a vertically opposite angle to angle ABE. So that angle should be 39 degrees. The reason is vertically opposite angles are equal. For D, you were asked, what's the sum of angles BCD and CDB? So BCD and CDB. Well, we know that this angle here is 39 degrees. Because it's vertically opposite to this angle. So whatever is left will be 180 minus 39 degrees, which will be the sum of these two angles, which is what is being referred to for question D. So the reason is angles in a triangle sum to 180 degrees. Next, you were told angle BCD is 70 degrees. Is triangle ACD isosceles? Is triangle ACD isosceles? Of course, no. All right? Triangle ACD is not isosceles. Why? Because the base angles of an isosceles triangle must be equal. And we can see that these base angles are not equal. If they were equal, we would have hatch marks here, but we do not have hatch marks here to show that. Pause the video and answer question 5 in 4 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. So for question 5a, you were asked, complete the sentence for each diagram. You must use correct mathematical vocabulary. Angle ACD is 118 degrees. Why? Because angles on a straight line sum to 180 degrees. How do we know that? To get this, we simply do 180 degrees minus 62 degrees. Here, angle WOZ, WOZ, note the way the angle is done. The middle letter tells you the angle you're referring to is 134 degrees. Why? Because vertically opposite angles are equal. So I'm going to rub this off before we discuss questions. Before we discuss questions C and D. Okay. Angle PSR. Angle PSR. Okay. Note the middle letter. It refers to the angle we're discussing, PSR, is 77 degrees because angles in a quadrilateral sum to 360 degrees. And you can see that the way to do that is to add them all up and subtract from 360 degrees. Next, this one, need to rub that off. Angle JLK, angle JLK is 83 degrees because angles on a straight line sum to 180 degrees. So if we do 180 degrees minus 97, we'll get this angle here. Or you can do angles in a triangle sum to 180 degrees because we can simply add these and subtract it from 180 degrees to get this angle. And that brings us to the end of our lesson. So we have used our knowledge of properties of triangles and quadrilaterals to solve interesting angle problems. Well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself and bye-bye.